that's available to the general public or to the outside users, and then a stronger level of access controls for the people who are administering or updating and changing the content on the page. Account management is important because if you don't keep track of who your users are in your directory, then how can you enforce their access controls? So that's one of the areas that's important for implementing confidentiality. And then, of course, the different ways in which you would authenticate people, whether it's just user passwords or whether you need biometric authentication or whether you need some kind of card, like a CAC card or a smart card. And then, of course, knowing who people are is only part of the problem. You have to be able to associate the privileges that go with the information. The data has to be labeled as to which things different users can have access to. Who owns the data? What is your procedure for backing up and recovering the data, for example? How do you store it? That type of thing. So those are all part of confidentiality. Integrity includes a whole set of things that are there to ensure that the information is not altered or can be restored if it is damaged or lost. And I think we're all familiar with backing things up and having a way to restore that. We also need a way to test that and verify that, as well as to protect information from being altered by viruses, worms, or other malicious content that might be trying to destroy that information. Of course, availability is important. If we have a service that our business depends upon, we may look at how are we backing up that information. Do we need to have a redundant site available online as to handle the capacity so that we're not taken down by normal usage or by potential outages. We're looking at the contingency planning for disasters. You know, when Katrina hit, that affected a lot of systems that were operating in New Orleans. So you have to look at national, regional disaster type issues, depending on the nature of the business. Another thing that is also associated with some of these things is non-repudiation or accountability. If you're running an online e-commerce site, you need to be able to prove that somebody who placed an order with you really placed that order, so that if they deny it and say, I didn't buy that, you have some way of assuring yourself that you have measures to enforce that purchase to avoid fraud type of issues. And so when we're looking at how do we go in and now translate these into a design in our system that will satisfy these types of requirements, we're looking at some fundamental principles. And I'm just trying to highlight some of the major ideas here, that certainly these can be expanded into a lot more detail, depending on the nature of what you're doing. But the fundamental principle is separation. And when we talk about the enclave architecture, we could see quite obviously how the enclave architecture provides separation. It separates trusted and untrusted parts of the systems from each other. We're also looking at a least privilege concept where people do not have access to things that they don't need to have access to. External users accessing the public area of the enclave architecture do not need to have access to the internal systems. And then another concept that's a little more complicated is the one of interdependency analysis. And what we're looking here is that when we apply our security measures to our system, to our design, it doesn't do any good to apply it inconsistently across the system. So if I have some things where I'm applying strong security, and then we have other things that maybe have no security applied to them, then I have not treated that consistently. It's, for example, if I have a room and I put a very expensive lock on the door, but I have a glass window on the door that people can just punch out the glass, then obviously there's a lack of balance there in terms of the strength of the mechanisms that are applied. So when we apply security into a design, we're trying to have at least an equivalent level of treatment. I talked about separation as a fundamental principle. Really, in applying separation, we have to think about not just the data itself or the systems themselves. We have to look at the users of that information. In what way am I separating basically the trusted users from the untrusted users? In terms of how they connect to the systems, what systems they're allowed to connect to, and then the communication paths. What am I doing to protect the trusted communication paths from the untrusted communication paths? In terms of the responsibilities of the people, how am I separating those responsibilities? Do I have one person who is administering the system and is also doing the security management? Those should be different functions so that you don't have a single point of failure. If somebody makes a mistake, even if it was well-intentioned, there will be no opportunity to catch that if there's no other people involved in implementing that. And then we're looking at segregating the data both while it's stored as well as while it's being accessed. So, for example, if I have a public server, I don't want to use that same physical box for both my internal trusted uses as well as my external public users. I want to use different systems, different physical systems, and not just trust, the operating system to separate internal users from external users. So those are just basic fundamental concepts of doing that. And as part of, I mentioned the least privilege enforcement, the general concept here is that in general, access is denied to information except where you specifically need to permit it. Now we'll see later where that fundamental approach creates issues when you're looking at sharing information. And we already talked about interdependency analysis, that we need basically a balanced view of how they tie together. So when we're looking at implementing the architecture, we now go back and we take all the requirements that we've maybe listed on this system. And now we need to go back into, let's say, if you could imagine a drawing of your system, you should be able to take each of the requirements and identify exactly where in your design that requirement is being satisfied, whether it's being enforced by the firewall, enforced by an intrusion detection system if we're looking at monitoring, whether I have a vulnerability scanner that I'm using to basically assure that my system is configured correctly, that I have antivirus systems to protect me against malicious code, or that I have VPNs maybe to separate my trusted user communications from my untrusted users, that I can have systems to provide strong authentication where I need that, and that I have cryptographic systems to provide cryptographic separation of maybe some internal activities from public external access. So we're really looking at that whole defense in depth process and how we design a particular solution depending on what my application is. So the general approach is to have a formal way to first document what your requirements are and then to translate those into how they're actually built and implemented on the actual system that's being fielded. Now, when I look at all these different systems doing different things, one of the mistakes that's often made is to think that all of these systems provide protection. Turns out very few things provide any protection at all. A lot of other things provide measurement or provide supporting capabilities, but by themselves provide absolutely no protection. The only things that actually provide protection enforce the separation and apply the least privilege enforcement. Things like, for example, firewalls. Things like intrusion prevention systems that actually deny something from happening. Things that may be reviewing content and blocking content that's not satisfying certain criteria for me even being allowed into a system or out of a system. Things that are limiting access to a host. Things that are limiting your access to an application program like a database. Those are providing protection. If I have an intrusion detection system or a vulnerability scanning system,